In this video, we are going to be learning about the chain rule. The chain rule in derivatives basically states that if we have a composite function, which is f of g of x, then the derivative will be f prime, so the derivative of f of g of x times the derivative of the inside function, so the derivative of g of x. So think about it as the derivative of the outside multiplied by the derivative of the inside. So that is the main chain rule formula, but there is also a power rule combined with chain rule formula, and that is y prime equals, so if we have, first we need to write the original function. So if we have y equals u to the power of n, so let's say this is u equals another function, we'd have the value to equal n times u to the power of n minus 1, and then we have to differentiate the u, so that's multiplied by u prime. So yeah, those are the two chain rule formulas. So the second one is just power rule and chain rule combined. So let's get started with the first question. The first question asks us is, what is the derivative of two x plus 9 to the power of 5? So yeah, find the derivative. Okay, hopefully you've paused the video. So on the inside we have, for the inside, the derivative is 2x plus 9, and on the outside the derivative, so imagine this section to equal u. So if we let u equals 2x plus 9, then the derivative of u to the power of 5 is 5u to the power of 4. So since we've differentiated the inside and the outside, when we combine them together, we get 5 times 2x plus 9 to the power of 4 multiplied by 2. So if you still don't understand, remember, it's the derivative of the outside multiplied the derivative of the inside. The derivative of the outside, in this case, it means if this was treated as one term, and let's say the highlighted part was u, then the derivative of the outside would be u to the power of 5 multiply the derivative of the inside, and the derivative of the inside is 2, because the derivative of 2x plus 9 is 2. So yeah, and now if we combine like terms, we get 10 times 2x plus 9 to the power of 4. And this is our answer. Okay, on to the next question. What is the derivative of 3x to the power of 4 minus, 3x squared minus 4x plus 1 to the power of 4. So find the derivative of that. Okay, so step 1 is obviously differentiate the outside. So if we let u equal 3x, this is plus 1. 3x to the squared minus 4x plus 1 to the power of 4. So the outside would equal 4 times 3x squared minus 4x plus 1 cubed. So we basically used the power rule to differentiate the outside, and now we multiply it by the differentiation of the inside. So when we differentiate the inside, so if you multiply it, so the derivative of 3x squared is 6x minus 4, because that's the derivative of negative 4x. So minus 4. And now, if we combine like terms, we'd get if we combine, so 6 times, so this would be 24x minus 16 times 3x squared minus 4x plus 1. And this is the derivative. Okay, on to the next question. So for the next questions, we are going to be doing or using, start using trigonometry. So you're going to want to memorize the derivatives of your trig rules. So I'm just going to write them down one more time for you guys to remember. You can skip this part of the video if you do remember. Okay, so the derivative, I need to space this out more. Sine of x. So the derivative of sine of x is equal to cos x. The derivative of cos x is equal to negative sine x. The derivative of secant x is equal to secant x times tangent x. The derivative of cosecant x is equal to negative cosecant x multiplied by tangent x. Oh no, sorry. It's not tangent x, it's cot x. the derivative of tangent x is equal to secant squared x. And the derivative of cot x, cotangent x, is equal to negative cosecant squared x. So those are the trig derivatives that you need to memorize. So yeah, let's get started on our first question. So, what is the derivative of sine of 8x minus 3? So hopefully you've written down those trig values. Yeah. So hopefully you've unpaused the video and you've finished working on the question. So let's get started. First, we need to differentiate the outside. So the outside, if we represent this 8x minus 3 as just u, so then sine of u would differentiate to cos of u. And now when we sub back in u, we get the value of 8x minus 3. Now we need to differentiate the inside. So the inside differentiated of 8x minus 3 is 8, so we multiplied by 8. And we can just move 8 to the front, and you get 8 cos 8x minus 3. And this is our answer. And that is that differentiated. So let's move on to our next question. So what is the derivative of cos 3x squared plus 2 So pause the video and solve. Okay, hopefully you've paused the video, and let's get started. So first, as always, we need to differentiate the outside. So if we let 3x squared plus 2 equal to u, so we let u equal 3x squared plus 2, then cos of u will turn into, if you differentiate it, so this would become negative sine of u. And the derivative of the inside, so d over d of x of 3x squared plus 2, that differentiated would be 6x. Okay, now we have all our components, so if we sub back in u, 3x squared plus 2, and then multiply it by the inside value, so outside multiplied by inside, the derivatives of those. So we multiply it by 6x. So in the end, our answer is negative 6x multiplied by a sine of 3x squared plus 2. And this is the answer. Okay. Hopefully you got that question right. And let's move on to some harder questions. So for this question, let's do... I moved on to integrals by accident. Okay, what is the derivative of tangent 5x cubed minus 2x? Pause the video and solve that. Okay, hopefully you've solved that question, so let's get started. So if we do the differentiation of the outside, so we take this as u, so if we set u equal to 5x cubed minus 2x, so tangent of u, so remember we're differentiating the outside, so tangent of u is equal to secant squared of u. And now we have to differentiate the inside. So the derivative of 5x cubed minus 2x. So that is equal to 15x squared minus 2. So if we combined all of this information, we get secant squared of 5x cubed minus 2x multiplied by 15x squared minus 2. And it's usually expected that the term, so the second term usually comes first before the trig value. So yeah, this is our answer. Okay. Let's move on to a harder question. So what is the derivative of the natural log of 3x plus 2 all raised to the power of 6? Yeah, derivatives use a lot of parentheses. Okay, so pause the video. Oh, and if you don't know what to do about the log of e, so the natural log, you have to remember that this is, you just memorize. You would just memorize this, but I might do a video on the proof of this, but the derivative of the natural log of anything equals, what was it? Yeah, so that always equals 1 over x. So the natural log of x will always equal x. Okay. So pause the video and solve that question. Okay, hopefully you've unpaused the video and you've solved the question. So let's get started. First, we have to, if you remember from before, this question. So this question and this natural log question, they're basically almost the same thing, except there's a log in the front. So, yeah. Basically, we have to, and the terms for us, this term and this term are basically the same. So we're just going to do the same steps for both. So let's get started. First, we have to differentiate the outside power. So, differentiating that, we'd get 6 times the natural log of 3x plus 1 to the power of 5. So that's the outside differentiated. And now for the inside. So the inside is this. So d over d of x of ln 3x plus 2 Oh, and I forgot to write for this, but basically we didn't have a coefficient here, but since it's not really a coefficient, but so since we have 1 here, the coefficient just transfers here. So not coefficient, the derivative, that just transfers to the top. So you just multiply by 1, since that's the derivative. But for us, the derivative, this would equal 3 over 3x plus 2. I guess a better formula for the derivative of a natural log would be d over d of x of the natural log of x. So then that would equal the derivative of x over x. Yeah, so that is the derivative of the inside. So now if we combine both of these terms, we'd get 6 times ln of 3x plus 1 to the power of 5 multiplied by 3 over 3x plus 1. So 18 times ln of 3x plus 1 to the power of 5 over 3x plus 1. And this is our answer. So yeah, that is the chain rule. This is only going to be part 1 of my videos. There's going to be harder ones. So to give a sneak peek of what one of the harder questions might be, here's one of the questions. So this is what I'm going to be doing in the next video if you guys want to try. So what is the derivative of, it's going to be a lot of parentheses, cos of sine of tangent of 2x squared minus 3, so a lot of parentheses, all raised to the power of 6. So that's just one question I'll be doing. But if this seems hard to you, don't worry. I'll be doing questions that go up from that, so it'll all make sense. So yeah, thank you for watching, and see you in the next video.